Good morning. In today's lecture, for the first time, we'll start talking about compounds that have functional groups. The specific class of compounds we'll discuss will be halogenated hydrocarbons. Halogenated hydrocarbons are simply hydrocarbons in which one or more hydrogens have been replaced by halogen atoms, and they can be divided depending on the type of carbon we're talking about into alkyl halides, vinyl halides, and aryl halides. Alkyl halides will be the class we'll talk about today at length, and they're characterized by the bond between sp3 hybridized carbon and a halogen, which we'll label as X here. Examples of this class are things like chloroform, very common solvent, various freons, which are used as refrigerants. This is an example of freon 22. And then various other solvents, such as 1,1,1 trichloroethane shown here. Vinyl halides and aryl halides both share the bond between sp2 hybridized carbon and a halogen, except that in case of aryl halides, this bond more specifically is the bond between an aromatic ring and a halogen. When it comes to vinyl halides, many of them are precursors to polymers, so this would be vinyl chloride, which is a precursor to polyvinyl chloride, which is of course a very commonly used polymer, while this would be tetrafluoroethylene, which is a precursor to Teflon, which is a polymer that is used in many applications because it's very inert, among others for non-stick pots and pans. Among aryl halides, many of them are common. This would be the so-called Paradichlorobenzene, which is used for mothballs, for example. Its isomer, orthodichlorobenzene, is used as a very common solvent. And so on. In terms of the nomenclature of haloalkanes, this nomenclature is really a very straightforward derivation of nomenclature of alkanes. Basically, halo groups are treated as substituents, so F would be a fluoro substituent, Cl would be a chloro, Br would be bromo, and I would be iodo. And using these four names, we basically develop names of haloalkanes the same way we develop names of alkanes. These can be treated just like methyl groups or any other alkyl groups. And to illustrate that in an example, this will be 1-fluoropropane. If we have a stereocenter, then we also need to define that. So in this compound where we have a bromine, hydrogen, methyl, and an ethyl group all bound to the same atom, this is a chiral center, and this would be R2-bromobutane. We can also have a substituent in a ring. This would be iodocyclohexane. Or if we have two substituents, then again we name them alphabetically. So this would be 1-bromo, 2-chlorocyclopentane. And since the two substituents on the opposite sides of the ring, this will be a trans isomer. They can also be parts of more complex substituents. So in this case, when we have a heptane with this branch coming off, that contains fluorine in it, then this compound could be named as 4,2-fluoroethyl heptane, and so forth. As I mentioned, many of these halogenated hydrocarbons are common solvents, and as such they have trivial names which still persist very much. We will use only a handful of them, such as trivial name for carbon tetrachloride, which will be carbon tetrachloride, also a very good solvent, but now very difficult to find because it destroys the ozone layer. A UPAC name for this will be tetrachloromethane. Another example of a solvent is this molecule of chloroform, which we already mentioned, which will be a trichloromethane. And then methylene chloride, also common solvent, and systematically known as dichloromethane. In terms of the classification of alkyl halides, we again can speak about a methyl halide. But then if we get into more substituted systems, then we can talk about a primary halide, which are those which have halogen bound to a primary carbon atom. Then we can have a secondary halide, and finally tertiary halides, such as this T-butyl halide, where halogen is bound to a tertiary carbon. Finally, just one brief note about dihalides. We can have many different examples of dihalides, but two that have used common names are these geminal dihalides. The words come from Gemini, which means twins, where both X's on the same carbon. Or in cases when we have halogen substituents on adjacent carbons, these will be the vicinal halides, where X's are on adjacent carbons. And this also comes from, if you speak Spanish, what vecinos, which means neighbors, describe this relationship. In the next topic, we will see what halogenated hydrocarbons are used for. They have many common uses in industry and everyday life.